circle to figure out problems here. And to start off with, let's go to the back. If you wrote in this one, that's okay, but to kind of figure out the connection between everything, I'm just going to use this single one that we have left over from the last time. If you've got it available, just go ahead and take notes and follow along. So what angle is this? Ooh, 30. A 30-degree angle right here. All right, so on our unit circle, what's the radius? So what's the hypotenuse? 1. Okay, so a 30, 60, 90 triangle. How do we get from the hypotenuse to the short leg? Divide by 2. So the short leg is?
1/2.
1/2. And how do we get to the long leg?
Multiply by square root of 3.
So the long leg is how much?
1/2. Oh, that's from the small leg. So
Square root of 3 over 2. All right, so those are our 3 lengths that we have on here. Sine of 30 degrees. Sine is what over what? What words?
O over H.
Okay, opposite over hypotenuse. All right, let's label our triangle. What is 1? Hypotenuse. What is 1/2? Opposite. And that leaves adjacent for the square root of 3 over 2. So opposite over hypotenuse, what is that for 30 degrees?
1/2, which is 1/2.
1/2 over 1, which of course, like you said, is 1/2. All right, moving on. Cosine of 30 degrees. Cosine is what over what? All right, adjacent over hypotenuse. So what numbers go there?
Square root of 3 over 2.
And the hypotenuse? 1. So our final answer is still square root of 3 over 2. All right, the tangent of 30 degrees. Opposite over adjacent. So what is opposite?
1/2 over
1/2. Adjacent, square root of 3 over 2. All right, when you have fractions stacked like this, these actually, the denominators actually divide out like that. You're more used to seeing it, let me write it the way you're more used to seeing it, that you have 1/2, and I multiply by the reciprocal, which would be 2 over the square root of 3, and so then we see how those 2's divide out as well. So the same thing, but if you can remember it, I don't use it too often, so I don't remember too. I have to think about it. We'll just say it that way. All right, so 1 over the square root of 3. How are we going to simplify that? Right, multiply by the square root of 3 over the square root of 3. So my final answer will be the square root of 3 over 3. All right, let's look at these 3 numbers. Now those ought to look sort of familiar from the other side of your worksheet on your unit circle. Okay, so here's that 30-degree angle, and we've got the square root of 3 over 2. So we were calculating those values and just listing those ordered pairs when we created the unit circle, because we didn't have enough information at that point to know that it represented anything else besides a length and a width. But now that we've added our trig component to it, we know that sine is opposite over hypotenuse, so that's 1/2. Cosine of 30 degrees adjacent over hypotenuse, so the square root of 3 over 2. So these values here are the values of sine and cosine for all of these different angles. They're the exact values. Okay, so which one's first? What's this one? Cosine or sine? Cosine. Okay, and this one is sine. So when you're looking at your ordered pairs, the first one is cosine. I'm just going to put an x, but you could also have a theta. And the second one is sine.
Wait, what's the theta?
Theta is just another variable that's used in angle measures. It's like a circle. This right here is the theta. Whoops, sorry.
Yeah.
Yeah, it's just like an x, but different variable. Okay, well, let's see. Let's go back and what about tangent? How does that come about? Now, when we look what happens, we've got our opposite over adjacent. Now, both sine and cosine have a hypotenuse in them, right? But tangent only is opposite over adjacent. So what's happening when we do this is that hypotenuse is well, let's see, not quite there. But anyway, the hypotenuse is going out of the picture, and we're just having the opposite over adjacent. So when we look at this, what is our 1/2 is right here. It's also sine of 30, okay? And the square root of 3 over 2, that's our adjacent, is our cosine of 30. Okay, so one of the things that you need to know is that tangent of an angle is equal to the sine of the angle divided by the cosine of the angle, because of the opposite over adjacent. And so essentially what's happening is the hypotenuses are canceling each other out, and we just have the opposite over adjacent left over from our sine and cosine. Okay, now let's use what we know, to work on the worksheet that I gave you. Okay, so how are we going to do that? So the first thing, first off, is copying and pasting, and didn't quite do my changes correctly. So that one's a duplicate, so we're just going to do it right here. So number 9, don't need to do again. So the first one says, what is the sine of 2 pi thirds? So I look at my unit circle, and I find 2 pi thirds. Found it. Okay, which one of these is sine? Negative 1/2 or the square root of 3 over 2? Square root of 3 over 2. Good. All right, so that's how we're getting started to using our unit circle. Just saying, okay, what is this value? So this would be the same value that your calculator would have in it. If I typed in, well, you don't. You're going to have to memorize some of it, yeah. All right, let's look at number 6. What is the cosine of pi? Okay, so pi is right here. Remember, it's cos first, then sine. And so we have -1 for the cosine of pi. All right, let's look at that tangent of 3 pi fourths. So tangent is equal to what divided by what? Not opposite over adjacent, but what? Sine over cosine. Good. Okay, so it's the sine of 3 pi fourths divided by the cosine of 3 pi fourths. All right, so we're going to look each of those up on our unit circle. The sine of 3 pi fourths is which one? Square root of 2 over 2. Okay. And the cosine of 3 pi fourths? Negative square root of 2 over 2. Okay, so this is just the same number. You don't have to worry about a whole lot. A number divided by itself is 1, right? But we have a number divided by the negative of itself, so we get what? -1. Very good. All right. Do 3 and 4 right now. I would say look on your phone for now. Okay, yeah, because you're going to be distracted by trying to fill it out and not following along. So just use the one that you took a picture of. Three and 4. What y'all get for number 3? Square root of 3 over 2. How about number 4?
Square root of 3 over 3.
Okay, square root of 3 over 3. Good job. All right, so number 3 we're just looking up on the unit circle. And so it's in the fourth quadrant, just below the 2 pi. And then we're looking at the tangent of 7 pi 6. We're looking at sine of 7 pi 6, negative 1/2. Cosine is negative square root of 3 over 2. The 2's, divide out. And so we're left with 1 over the square root of 3, just like we did over here. So I just kind of went straight to the answer since we already did that once today. All right, let's look at problem number 11. The numbers are all messed up down here. Again, that copy and pasting that I kind of rushed through, I guess. So you got two numbers at 11, and on the top they went down, on the bottom they go to the right. But anyway, just work the problems. So we have sine of 45. So we're looking at degrees this time. So what is sine of 45? Square root of 2 over 2. And then sine of 135. Square root of 2 over 2. All right, so we can think of that like 1 square root of 2 over 2 and a 1 square root of 2 over 2. When we add those together, how many of them do we have? 2. Square roots of 2 over 2. And those 2's will divide out, and so our final answer will just be the square root of 2. Okay, do 12 and 13. The first 12, these two right here. – 12 and 13, yes. To the right and below. You might want to try this one over here. Yes, please. All right, so this time we have cosine of 45. How much is cosine of 45? Square root of 2 over 2. Same thing as sine on 45. How about cosine of 135?
Negative.
Okay, so this time it's negative. So we're just looking that up on the unit circle. So cosine is the first one. Here's the 45. So there's my square root of 2 over 2. Here's the 135. Cosine is the first one, so we have our negative right here. Add them together and we just get 0, right? Okay, so the cosine of 300. So 300's all the way over here. Cosine is what? 1/2. Okay, this time it's sine of 150. So 150 is here. Sine is which one? 1/2. So we get 1. All right, we're going to move on. Whoops. All right, so we're looking at these problems to see the connection between everything that we've been doing over the past week with the special right triangles and with the trig. Now, you're not going to work the problems this way realistically when you're taking the test. You should work this problem using special right triangles. We should know the answer ahead of time. I'm just trying to work this problem to make you see the connection between all of these pieces that we've been working on. All right, in a 30, 60, 90 triangle, if this is 10, then what is x? 5. And what is y? 5 square root of 3. Okay, so those are the answers we know we should get. This is a little preview of how the unit circle will be used in the future, but not, not the full thing. All right, so let's work this problem using trig. So opposite is x from the 30, and then I have adjacent here at y, and I have a hypotenuse at 10. So if I want to find x, what am I going to use? Sine, cosine, or tangent? Using the 30-degree angle. Sine. All right, sine of 30 is equal to opposite, which is x, over hypotenuse, which is 10. All right, what is the sine of 30? Look on your unit circle. What is it? 1/2. Sine of 30 is 1/2. So in place of sine of 30, I'm putting in 1/2 equals x over 10. All right, and so then I get 2x equals 10, and x equals 5. working it in an extremely different way than the other ways that we have worked this problem before. Now we're going to find y. So what do we use to find y if we're using the 30-degree angle? Cosine, because we have adjacent and hypotenuse. So cosine of 30 is equal to adjacent, which is y, over hypotenuse, which is 10. What is cosine of 30? Okay, from our unit circle, it's the square root of 3 over 2. So 2y equals 10 times the square root of 3. Divide by 2 on each side. Y is equal to 5 times the square root of 3. Which is exactly what we got the other way. I mean, it just all works together. Let's do with this one with the 45, 45, 90. And let's put away any other devices that we might be using right now instead of paying attention. So how many degrees are these angles?
45.
45. All right. It doesn't matter since it's 45 whether we use sine or cosine, right? Because they're the same value at 45, right? So I'm just going to pick sine. I'm going to say opposite, because I put the 45-degree angle there, and hypotenuse here. So sine of 45 equals opposite, which is x, over hypotenuse, which is 16. So again, we're looking at the sine of 45, which is right here, square root of 2 over 2. We'll replace sine of 45 with its value, square root of 2 over 2. Get x over 16, or still equal to x over 16. So 2x is equal to 16 times the square root of 2. Divide by 2 on each side, and x is equal to 8 times the square root of 2. Okay, again, the goal on these problems is not that you work these problems this way, but that you see the connection between the special rights, the unit circle, and the trig. Okay?